All right, guys, welcome to pre-calculus. This is 2.3.3, and we're going to be talking about tangent and its inverse today. So, to start off, we're going to be, again, this is a thing which I would typically have you do on a handout, but we can kind of remedy that if you would like to draw just a standard graph. It doesn't need to be fancy, and then draw the cosine curve for one interval from negative pi up to positive pi. So this looks like that one normal kind of bump, right? Draw that out, and then we can kind of work through this together. So what we're going to be trying to do is first we're going to note any time where cosine is 0, and then what does that cause to happen? Mark that on our graph. Then note whenever our sine is 0, note that on our graph, and then we're going to try and use the table we've gotten in the past to actually plot points and graph this out. So I'm going to hop back over to this. So our first question is, well, what happens when our cosine is 0? Now, if you have your unit circle, right, we made this chart. This is a printed off one, so it has a bunch of stuff we haven't gotten to yet. But my cosine being 0, well that happened at pi over 2 and at 3 pi over 2. And whenever that's 0, I'm undefined for my tangent, because again, tangent is sine divided by the cosine. So this is when I'm dividing by 0, so I can't do it, so it's undefined at those values. And whenever I'm dividing by 0 on a graph, I get a vertical asymptote, or the vast majority of the time I get a vertical asymptote. So why they kind of drew this here for us as a reference point is, well, at here and here, I should have asymptotes. So I'm going to kind of sketch those in. As I'm going to have asymptotes at these points. Okay, that's the kind of key thing there. Now, the second thing it says is, well, what about sine? Well, when sine is 0, my tangent is always 0, because tangent is just sine divided by cosine. And if I have 0 divided by anything other than 0, I always get 0 out of it. So I get 0 there at 0, at pi, and at 2 pi is when that happens. So at 0 and at pi, and then at 2 pi, I don't have 2 pi here, but it would also happen over here at negative pi. So I'm going to be crossing my axis at those 3 points. Right? So now if we actually go to the graphing portion, right, and look at the values here, this is where I'm going to use a calculator to estimate these, right? If I wanted to figure out, well, how could I graph rad 3 over 3? I do square root of 3 divided by 3. That's approximately 0.57 or 0.58. So that would be at, this is by 12th. So this is going to be for 6th. I'm going to be here, so 0.57. So I'm like there-ish, a little bit over the 0.5. And then at pi over 4, we're going to be at 1. And then at pi over 3, we're going to be at rad 3, which I want the square root of 3. That is approximately 1.73. So we're going to be kind of there-ish. And then the next value which I have is too high, right? And then this is going to kind of mirror down, but over here in the negatives. So I'll be over here, and then there, and then there. So that's kind of one cycle. Now we kind of know what this is going to look like, but it'll go up, and then I'll just kind of follow that asymptote as it goes up, and this will kind of go down, and follow the asymptote as it goes down. Now if I go over to this side, this is going to be the exact same values as these. So there, there. there, and then I'll kind of do that number, because again, follow it, and then over here is going to mirror it. So it'll be there, and there, and there, and I'll mirror it up. Again, that's just if we take all of these values from our circle, since these kind of follow that pattern. You can just kind of, once we found those base ones, we kind of knew what that pattern was going to look like. So there's my sketch of my graph of tangent. Now, if I keep this going to the right, I'm going to see this part repeated right here. So it's really this shape repeated again and again and again as I go each direction. So this is really all I need to kind of know what my shape is. It's this thing, but repeated. Kind of like sine and cosine, where that one cycle, we repeated this. One cycle for a tangent is right there, right? Okay, so let's hop back to this. Answer, hey, what is the domain of tangent? Well, we can tell it's all real numbers except it's all of these parts where cosine is 0, right? So it's everything but negative pi over 2, positive pi over 2, then it would happen again at 3 pi over 2, and so forth, right? So really, it's pi over 2 plus 2 pi plus 2 pi, sorry, plus pi n for some integer n, right? Because it's every n, I'm going to see that same asymptote throughout the entire thing. So my domain for tangent is a little bit more restricted because of that whole dividing by 0 thing, but it follows a pretty easy pattern. So it's, hey, it's whenever the cosine 0, or to be a little bit more formal, it's pi over 2 plus pi n for some integer n, or all values of x except for pi over 2 plus pi n for some integer n. Again, I'm not going to ask you to write that out. I just hope you kind of see why that is and what is going on there. Second question here, what is the range of the tangent? Now this is drastically different from sine and cosine, right? Sine and cosine were from -1 to +1, that's it. But for this, these go down forever and up forever, so my range is infinite. It's all real numbers on this one. So tangent is definitely drastically different there. What are the x-intercepts of the function? Well, that happens, we saw at 0, at pi, at 2 pi, at negative pi. So anything which is some number pi, right? So some integer pi is going to be all of my x-intercepts for that one, because that, again, happens whenever my sine value is 0. Explain why the f of x is equal to x has asymptotes. So as we kind of saw, that's because the cosine being 0 causes us to divide by 0. And dividing by 0 is what causes those asymptotes. And the equation we already kind of went over that when we talked about the domain of the tangent. When is the tangent of x less than 0? When is the tangent of x greater than 0? This is a fancy way of saying, hey, when is it negative? When is it positive, right? So if I look at my graph here, I'm positive from 0 to pi over 2, and then I would be positive again from pi to 3 pi over 2, right? And then I'm negative from negative pi over 2 to pi, and then from pi over 2 to pi, from negative pi over 2 to 0, and then pi over 2 to pi. So it's going to be a little bit easier for us to see that on the unit circle, right? So in my quadrants, right, the tangent is sine divided by the cosine. So here it's positive divided by positive, so I'm positive. Here it's positive divided by negative, so it's negative. Here it's negative divided by negative, so it's back to being positive. And then over here it is it's negative divided by positive, so it is negative once again when I'm over here, right? So my tangent is positive in these quadrants, negative in these quadrants here, right? Okay. So, what is the period of the tangent of x? Is it the same or different from the periods of sine and cosine? Now, here's a really interesting one, right? Oops, pull this out. So, how long is my cycle until it repeats? Well, it takes from here to here, and then I'm repeating, right? The distance from negative pi over 2 to pi over 2 is just pi, right? So my period is only pi for my tangent, right? For sine and cosine, both of those, it was 2 pi. Tangent, it's half of that, it's just pi, which makes it a little bit easier numerically to work up just because there's no 2 there. But it is different, which kind of makes it a little bit easy to get wrong because you're going to think of it, oh, it's they're all 2 pi, where tangent is the kind of different one because of it being that ratio of the sine divided by the cosines. Okay, is the tangent of x odd, sorry, even, odd, or neither? Use multiple representations to justify your answer here. So let's take a look at our graph, because the main way that you can say even, odd, or neither is by looking at the graph of it. Now, if I took this graph and reflected it over the y-axis, do I get the exact same thing? Heck no, right? That's obviously not going to be even for me. But then odd is if I do a vertical reflection, do I get the same thing as if I do a horizontal reflection, right? So if I reflected this horizontally, I would get this kind of shape here, right? And then this part would go over here, and then this part would go over here, right? Now if I did a vertical one, then this part would go here, this part would go here, this would go there, this would go there. So I really get effectively these same shapes, right? So this is looking like it's going to be odd, and it is going to be odd for us, right? You could do it algebraically, where it's a little bit more challenging because we don't really have the exact skill set for that quite yet, but in the future we are going to be able to algebraically show, hey, yes, this is going to be odd for us. All right, and then we're going to add this to our paragraph. That's basically means, hey, tangent, the base graph for tangent is something that I'm going to expect you to be able to kind of know in general what the graph looks like. So kind of add a little sketch of that to your like notes with those important parts like we kind of have here of the asymptotes at negative pi over 2 and pi over 2. We got those intersections there at negative pi, 0, and pi, and then we got that kind of curvy shape with the asymptotes following it. So just kind of, if you know that general shape, that's what we care about right now. Okay, so our next bit here is going to be trying to look at the inverse for tangent. So we're going to do the same thing as we did last time, where we do that kind of carbon copy thing. So I'm going to go ahead and pause the video here. I'm going to do that carbon copy, and then we're going to take a look at that and kind of go through this problem here. So if you would like to follow through with that, you can sketch your own. And this is just a fancy sketch of what we just did. We're going to draw over it, then fold it over the y is equal to x line, and then carbon copy it with our fingernail to kind of see what that graph is going to look like. So go ahead and pause and do that. Okay, so this is what we get once we kind of do that inverse graph with that carbon copy method for us. So again, theoretically, this keeps on going down up here and down here. So I'm clearly not passing my vertical line test, right? So I need to get rid of likely this portion and this portion, because then that middle area is going to be a function for me. Now it does kind of follow this asymptote there and an asymptote down there, but I'm never going to have any problems with passing my vertical line test because I'm going to get rid of everything down here and everything up there, and I'm good. So the portion that I want is going to be this area here. Now this does go off in both directions forever, so I'm not going to draw those kind of stopping lines. But what I do need to do as far as restrictions to get that is I would need to cut mine at these asymptotes, right? So pi over 2 and negative pi over 2. I'm going to want to be cutting my domain of my original there, so I just have that one kind of wiggle, right? And then when I do the inverse of just that one wiggle, I get this sideways wiggle, which goes off forever but stays a function for me there. All right, so heading back over here, we're going to restrict that domain to being from negative pi over 2 to positive pi over 2, just that one inverse kind of thing. So it's really the exact same thing as we did for sine, if you keep that in mind. And that's going to be it for the inverses there. So that reads us on to the closure, which is going to be a pretty important thing for us. Oh, sorry, notes first. Here's the domains and ranges we just kind of found for the sine and the cosine, and the new one we just did was the tangent. So again, feel free, like you can put those in your notes if you don't already have them. It's really just kind of going over what we did the past today and yesterday. So what is the period of the tangent of x? So the period is just pi, right? It's half of that of what it is for sine and cosine. But now my big thing here is the tangent can also be thought of as the slope of the angle. That's about, hey, why is that? And then what pairs of angles would have the same tangent and why? Well, if I go back over to this, right, our tangent is sine over the cosine. So it's this value over this value. That's your rise over your run, right? Your change in y over your change in x, okay? So really, that's how we find slope and how we found slope since pre-algebra, right? So looking here, this ends up telling my tangent ends up just being the slope of this line here, which is going to be the same as the slope of this line here, because this is just really one straight line through, right? This becomes the same as this as far as slope goes, this and this, the same slope, and likewise all the way around my circle, the angles opposite of each other have the exact same tangent because they have the exact same slope, right? So that's the kind of cool thing about where you see tangent on the unit circle, because sine and cosine are really easy to spot. It's the x and the y values, but the tangent, it's not explicitly shown to you here. But it's kind of it's hiding in plain sight. It's just the slope of all of these, right? So here, hey, my slope is 0 because it's flat. Here my slope is undefined because it's vertical. And likewise, and hey, that's exactly what we see when we find the tangents. Also, here's all my positives and positives because these are all positive slopes. Here's negatives and negatives because these are all negative slopes. So that's just a really cool thing which we kind of notice once we start working through these. All right. So homework-wise, here is our homework for 233, doing 153 through 160. And then this does finish off chapter 2 for us. So the next assignment that we are going to do is going to be the closure for chapter 2, which is going to be problems 161 through 172. And with that, I will talk to you guys next time.